Today, let's have the second module for the computer networks and security, which is all about the networking fundamentals. Wherein we're going to talk about the evolution or the brief history of computer networking, network connectivity devices, network topology, standardization and its benefits, network classifications and architecture, and the last topic, which is the OSI or the 7-layer reference model. Okay. So the earliest phase of electronic networking for the purpose of message transfer was the local telephone exchange, which has evolved to become a carrier network providing transport services for both voice and data traffic on a worldwide scale. So data networks designed exclusively for computing environments follow the introduction of business computing in the 1950s, wherein prior to that time, computers were used mostly for research and national defense purposes. So here is the milestone in the history of data networking, which includes, so let's start with the 1960s, wherein the first large-scale commercial computer network is created for an airline reservation application. Actually, this is also the time wherein the Advanced Research Projects Agency Network, or the ARPANET, successfully linked computers developed by different manufacturers, forming what is later described as the origin of the today's internet. So when 1970s entered the timeline, a networking technology for mini computers called Ethernet is being developed. During the 70s, computers were smaller in physical size, wherein mainframes as the central computer were replaced by a smaller computer called the mini computer, which from a networking perspective, function in the same manner as mainframes but on a smaller scale. So there are also terminals that link to a centralized processing and storage unit using cables or telecommunication circuits. So kung mapapansin ninyo dito sa mismong figure, this is actually a mini computer environment by which each of the department each of the department have their own mini computers. So compared with mainframes, fewer simultaneous terminal connectors, which is also called as sessions, are possible due to the relatively limited performance and storage capabilities of mini computers. Then 1980s, wherein there is an increase in the number of standalone desktop microcomputers within organizations, encourages widespread adoption of local area networks. So due to their low costs and the availability of all types of software, personal computers have been acquired in large volumes by organizations since the 1980s. So it was the time of their introduction wherein PCs provide a great deal of flexibility to users accustomed to requesting mainframe or mini computer services from data processing department. So the PC made it possible for any individual or group to choose, purchase, install, and operate a computer without the involvement of programmers or other computing specialists. So with the introduction of terminal emulation software, PCs could also access data on mainframes and mini computers, eliminating the need for terminal. So pag sinabi nating terminal emulation software, it enables a PC to assume the operating characteristic of various types of terminal. So the progress in computing and manufacturing technologies has made it possible to incorporate the processing and storage capabilities of desktop computers into portable devices such as laptops, tablets, personal digital assistants, okay? Gaya ng nakikita nyo dito sa mismong pictures na to, okay? This is what we call the personal computing devices. So we have the desktop computer, PDA, desktop telephone, tablet computer, laptop, and mobile smartphone. So similarly, current desktop and mobile telephones are capable of connecting to the same data networks as computing devices, so making them similar in capability to traditional PCs. Then, pagpasok ng 1990s, okay, so the web-based internet resources is being introduced on a global scale. Okay, so LANs were like islands. So pag LANs, okay, local area networks, were like islands of information system that were isolated from one another during the 1980s. But pagdating nga ng 90s, okay, the different vendors started to interconnect these different isolated LANs, okay, wherein this is the idea of what is known today as the internetwork. Pag sinabi kasi nating internetwork, okay, it refers to a collection of individual networks connected by intermediate networking devices that functions as a single large network. Okay, so as you all see in the figure, sorry if this is a blurred one, okay, it illustrates some kinds of network technologies that can be interconnected by routers and other networking devices to create an network. Okay po. So this is a collection of different network topologies. Okay, so from a WAN, then yung Ethernet, okay po. So yung mga topologies na i-discuss mamaya, okay. Ito 'yon. Okay po. So pagdating ng 2000, okay, which is classified as the new millennium, okay, there is an improved mobile or wireless devices, and networks provide the means to connect to an organizational network from nearly any location in the world. So as years went on, the advances in computing and communication technologies and the decline in costs have made it possible to provide each user with multiple fixed or mobile processing devices such as desktop, laptop, handheld devices, and home computers. Okay, each of these devices is independently capable of storing data and connecting to an organizational network, a home network, or the internet itself. Okay, this is in contrast to earlier times when all user had to share the processing and storage capabilities of a single centralized computer using desktop terminal. Okay po. So the evolution in computing can therefore be described as a migration from a centralized to decentralized papunta ng distributed. Okay po. With networks used to interconnect various types of computing and storage devices. Okay po. So next, let's have now the network connectivity devices. So when we say network connectivity devices, it includes any type of hardware that is capable of transmitting data, instructions, and information between the end user devices such as computers, scanners, printers, and etc. Okay, and there are so many network connectivity devices, and some of them is almost the same, yung kanilang mismong itsura, but then the functionality is different from one another. So this is really tricky if you're just going to rely on pictures, or sabihin natin you're just going to rely on the physical appearance of the network connectivity devices. So let's proceed with the repeater. Okay, so this is the first network connectivity devices that I want to introduce to you. So repeater is being used to regenerate the signal through taking in an incoming weak signal, then amplifies it or boosts its strength before it is sent to the rest of the connected devices. From the word itself, it's going to repeat. for example is yung may limitation lang yung mismong range ng internet. So you are going to use the repeater to boost it, to amplify it, para magamit pa siya on the latter part or weak areas. Okay, then next, let's have the hub. When we say hub, okay, this functions similarly as a repeater by means of a process known as concentration. Well, unlike the repeater, a hub can have multiple ports to connect to a number of network devices, which is why this device is also known as a multi-port repeater. Okay? So next, we have the bridge. Okay, so sa bridge naman, okay, this converts network transmission data formats as well as performs basic data transmission management through filtering traffic on a LAN and keeping local traffic local. Okay, so yet the connectivity to other parts or segments na tinatawag of the LAN for the traffic that has been directed there is allowable. Okay, in lieu of this, you may wonder how the bridge knows which traffic is local and which is not. So the answer is the same one that the postal services uses when asked how it knows which mail is local. So it looks at the local address. Okay, that's the answer on it. So it will going to look at the local address, and every networking device has a unique MAC address on the NIC or the network interface card. So the bridge will going to keep track of which MAC addresses are on each side of the bridge and makes its decision based on this MAC address list. So yun yung mismong function ng mismong bridge. So hopefully you understand it. So let's have the switch. Okay, wherein the function is similarly as a bridge in terms of connecting LAN segments. Okay, so it uses a table of MAC addresses to determine the segment to which data is going to be sent, and then i-reduce niya rin yung mismong network traffic. Okay, so in fact, this switch is called a multi-port bridge. Okay, same with the hub, which is called as a multi-port repeater. Well, the difference between the hub and switch is that switches make decisions based on the MAC address, and hubs don't make decisions at all. Because of the decisions that switches can make, okay, they add more intelligence to data transfer management. So they do this by switching data from only the port to which the proper host is connected to. So in contrast, okay, a hub will send the data out of its port so that all the hosts have to see and process. Okay, it's either accept or reject all of those data. Okay, so next, let's have the router. So the router, okay, this connects multiple computers or other routers together through examining the incoming data packets, choosing the best path for them through the network, and then switching them to its correct destination on a network itself. And the last will be the cloud. Okay, so actually the cloud is not really a single device, but a collection or a group of integrated and network hardware, software, and internet infrastructure that represent processes and equipment that will be involved in making a connection. Okay, so that's it. So those are the networking connectivity devices. Let's now proceed with the network topology. Okay, so gaya ng binanggit ko sa inyo last time, I hope that you still remember it. Okay, so during the introduction of computer networking, okay, computers must be connected to each other to be able for them to share resources or perform other communication tasks. So however, okay, this connection is not as simple as just plugging a computer into a certain medium to connect to other computers. Okay, so it will going to take planning in order to work properly and to determine, for example, the type of cable to be used and how the cabling will run through the floors, ceilings, and wall. Okay? Parang nangyayari dito kasi is you are an architect at the same time as the engineer of how you are going to plot, how are you going to make connection. Okay? Nakuha po. So, what do you mean by a network topology? Okay, so this will answer it. Okay, because network topology, okay, it refers to the structure of a network which includes the physical layout, design, diagram, or map of computer, cables, and other components on the network itself. So, meaning to say, it is a network blueprint. Okay, so in choosing an appropriate topology for your network, so there are some following things to be considered. First one is syempre yung cost of network management, yung cable length, and yung mismong growth ng mismong network. Okay, well, the term topology kasi refers to the way a network is being laid out. Okay, kung paano ba paano ang mangyayari sa kanya. Okay, so it's either a physical topology or a logical one. Pag sinabi nating physical, okay, it refers to the arrangement of the cable, network devices, and end system. Pag sinabi nating end system, it refers to the PCs and servers. Okay po. Well, pag on the other hand, pag sinabi naman nating logical, okay, it is the path that the data signals take through the physical topology. Okay, so a topology can be considered as a network shape. Okay, so kung medyo nalilito, okay, so that it is a topology can be considered as a network shape. It is a geometric representations of the relationship of all links. Okay pa. So, sir, it could be possibly na we have the physical topology and logical topology. Yes. Okay. So, now let's have the different physical topologies that we have. Okay. So, actually, under the physical topology, we have the bus, the ring, star, extended star, hierarchical tree, and the mesh. So, let's have the bus topology. Okay, so in this bus topology, okay, it is a network topology in which any of its devices is attached to a single communication line, okay, that carries messages in both direction. So ayun yung sinasabi nating bus topology. Whereas pag sinabi naman nating ring topology, okay, it is a network topology in which the devices are connected in a closed loop on which messages are received by one data unit from the previous device, and then it will going to regenerate it and forwards it into the next device. Okay, so in the ring topology, okay, we have two types. So the first type is the single one, which is the devices of this type of ring topology share a single cable and the data travels in one direction only. Okay po, one direction only. So each device, okay, waits its turn to send the data over the network. Okay? Then the single ring, however, is susceptible of a single failure, stopping the entire ring from functioning. Since there is only one cable that is being used in this single ring topology, for example, is naputol yung isang connection, okay? So hindi na makaka-receive ng data yung mga susunod pa. Okay po. So that's it. That's why if there is a single failure, okay, it will stop the entire ring from the functioning. So next, let's have the dual ring topology. So another type ito. So again, there are two types of ring. So we have the single and the dual. So for the dual, the data on this type of ring topology is allowed to be sent in both direction or in any direction. Okay? So there could be a possibly na may maputol man dyan na isa, it's okay. The ring itself, the topology itself will still run. Okay, will still function. Okay, so next, let's have the star topology. Okay, well, actually, it's really a star. Okay, kung ano man yung naisip yung drawing of a star topology, that it is. Okay po. So, ito yung pinaka-center and then maraming nakakonect na devices sa kanya. Okay, so that's the star topology in which in this topology kasi, okay, all of the devices are attached to a central device known as the hub. Okay, it could be a switch, it could be also a router. Okay, but again, okay, it is connected into a central device. Nakuha po. So we have also the extended star topology, wherein it connects the individual stars together, okay, through linking or through the use of hub or switches, wherein it extends the length and the size of the network itself. Ayan, kung mapapansin ninyo. Okay, so this is a single star, then another single star, then another single star. Okay, and then it is being connected. Okay po, na pinag-connect lang. So, kaya siyang tinawag na extended star topology. Okay, so the reason is to extend the length and the size of the network itself. So, let's have the hierarchical. Okay, so pag sinabi naman natin hierarchical, okay, it is actually similar to an extended star topology, except dun sa paglilink ng hubs or switches together. Okay, because each secondary system is linked to a primary computer that controls the traffic on that topology. So, ang mangyayari sa hierarchical is that meron silang node wherein yun yung pinaka magko-control ng mismong data communication dun sa mismong sa isang link. Okay po. So, ganun siya. So, hindi pala napapakita dito sa picture. But then, ganun yung mangyayari sa kanya. Meron dong isang single computer that will control the traffic over the topology itself. Okay po. So, next, let's have the tree topology. So, it is a network topology which has the characteristic of both bus, okay, both bus and star topologies, since it consists of groups of star configured workstation connected to a bus backbone cable. So, ayun, pinagsama siyang bus. So, meron niyang single connecting line. And then, ayun, meron, yan nga, yung mismong star topology. Okay po. Then, pinagko-connect sila in a single line or communication line. Kaya siya tinawag na tree topology. Okay, just like what a tree, okay, kung papansinin nyo yung tree, so it's like a trunk, and then ito yung mga leaves niya, yung mga stems. Okay po, so that's it. Next, let's have the mesh. Okay, so sa mesh, this is all, there is also a two types of mesh, okay, wherein kasi pag sinabi naman nating mesh topology, okay, it is a network topology that connects all devices or yung nodes na tinatawag for continuous connection. Okay po, and reconfiguring around broken or black paths by hopping from node to node until the destination is being reached. Okay, it is used in ones to interconnect LANs and for mission critical network like those used by banks and financial institution. Okay po, dun usually tagang ginagamit yung mismong mesh topology. Okay po, kasi hindi naman pwede na isang line lang or isang connection lang yung gagamitin nila, kasi nga this there is a delicate or a critical data na kailangan nilang ipadaan sa network. So, kung gagamit lang sila ng isang line doon, isang node, or yun nga, sabihin natin they are using a bus topology on their transaction, okay, there could be a possibly na ma-intercept yung mismong data, magkaroon ng mga security threat. Okay po. That's why they are using a mesh topology for at least na meron mga ibang pagdadaanan yung mga data na mga pinagsasend nila or tina-transfer nila, or yun nga, gumagamit ng mismong communication line. Okay po. So, we have the full mesh wherein each device or each node on this type of mesh topology is connected directly to each other. Okay, so yan, lahat talaga sila is connected sa bawat isa. Okay po. Yun yung full. When we say naman partial, okay, sa partial naman, okay, some nodes of this type are connected to all others, okay, and some of them are only connected to the nodes which they exchange most of the data. Okay, so hindi lahat yan is magkaka-connect. Okay po. Meron dyan na yung tipo na isang node lang, yung isang node is wala na siyang ibang ka-connect. Okay po. Yung parang siya na yung mismong dead end. Okay, meron, part din yun ng mismong mesh, partial mesh. Okay, so yun po siya. So next, let's have the advantages. Okay, let's talk about the advantages and disadvantages of this network topologies. So for the bus topology, okay, so advantages of a bus topology is that first is it is easy to set up and to maintain. Okay, usually it will just use a coax cable. Okay, then second one is advantage yung pinag-usapan natin, inexpensive in terms of cable use since it requires less cable length than a star topology. And lastly is it is easy to extend. Okay, so disadvantages of a bus topology is that problems are difficult to isolate if the entire network shutdowns. Okay po, kasi ganun din yun. Same with the ring topology. Okay, may masira lang dun sa isang part na yon ng mismong bus topology. Okay, yung mismong single line na yon na pinagdadaanan nila or yung mismong connection line nila is nasira, wala na din silang connection. Okay, kaya yun yung sinasabi natin na it's really difficult to isolate if there is a network shutdown. Then entire network shutdowns if there is a break in the main cable. Okay, so with this, so there are so many users that could be affected. Okay, lalo na nga yun nga yung sinabi ko kanina na pag yung mismong main line yung nasira. Then next is the network slows down in heavy traffic. Okay, kasi isa lang yung dinadaanan nilang communication line. So we have also the ring topology. So the advantages of a ring topology is that the system offers equal access and even performance despite of its many users. Okay, so this is due to the absence of collisions, which makes all the data to travel in the same direction. Okay. And then disadvantages is that failure of one computer and network reconfiguration disrupts the operation network, which impacts the rest of the network itself. Okay, so ayun, same with the bus topology. So pag nagkaroon ng isa dong failure sa mga points, okay, it could really bring havoc dun sa mismong network. Okay, so let's have now the star, tree, and the mesh topology. So for the star, okay, so failure of one computer does not affect the rest of the network itself. Okay, so the disadvantage is computers attached are disabled if hub or switch or concentrator fails. Okay, so for the mesh, okay, so individual segments use point-to-point wiring. Okay, so the system provides increased redundancy and reliability as well as the ease of troubleshooting. Yun nga lang, the disadvantage is that the system is really expensive to install. Okay, expensive to install because it employs a lot of cabling. Okay, so for the tree, individual, ayan, nagkabaliktad pala siya. So for the tree, so individual segments used to point-to-point wiring, and then yung mismong disadvantage is that if the backbone line breaks, the entire segment goes down. So ito yung para sa tree. Okay, and then ito yung para dun sa mesh. So nagkabaliktad po. So sorry. So that's the advantages and disadvantages of the star, tree, and mesh. Okay po. So yan, star, then this is the tree, and then this will be for the mesh. Okay po. So next we have the let's talk about the logical topologies. Okay, so there are actually two logical topologies, wherein the first one is the broadcast topology, in which dun sa mismong network topology na to, okay, it will work as a first come first serve basis. So kung ano man yung first line na makakuha, okay, ng mismong data, okay, yun din yung mismong data na una ring isa-send. Okay po. So each host on the LAN sends or broadcasts its data to every other host. Okay? So Ethernet, which is a network standard na gumagamit ng CSMA or CD access method, is an example of this type. Usually, mapapansin nyo itong CSMA or CD dun sa mismong mga lumang phones na wala pang network. or walang internet. Okay? So, pag sinabi kasi natin CSMA-CD, it is a carrier sense multiple access with collision detection. Okay? So, usually, ito nga yung sa mga lumang phones wherein uso pa doon yung group messaging. Okay? So, it refers to an access method in which station transmit if there is an available transmission medium and retransmit in the occurrence of collision. Okay po. So, ayun, di ba kung mapapansin nyo, for example, is yung mga late receiver, okay po, yung nagto-two parts ng messages, okay, so that's an example of a broadcast topology. Ayun nga. So, nagkakaroon ng mga submission just in case na magkaroon ng collision. Okay? And then, ayun, nagtatransmit na sila ng data if there is a transmission medium which is available. So next, let's have the token passing topology. So it is a network topology that controls the access through an electronic token. So possession of token gives the host the right to pass data to its destination. So pag sinabi nating token ring, okay, this specifies that the computers and devices on the network share or pass a special signal or yung tinatawag na token. And the fiber distributed data interface or FDDI are the example of this type. So, yung FDDI or fiber distributed data interface, it refers to a 100 Mbps LAN defined by ANSI that uses fiber optics, dual ring topology, and the token passing access method. Wherein today, yung mismong FDDI na to is ginagamit na siya doon sa metropolitan area network. Okay po. So, that's the two logical topologies. So, I'm going to end the discussion for the module 2 here and continue the other sa next meeting natin. Okay po. So, if you have questions, kindly message me or leave a comment here. So, thank you. So, that's it. You are being dismissed. Let's call it a day.